Welcome to Chapter 6, Chemical Equilibrium. Okay, now let's start with dynamic equilibrium. Okay, explain the following terms: reversible reaction and dynamic equilibrium. Now, before we go to reversible reaction, let us recall what is the non-reversible reaction. Non-reversible reaction can only proceed in one direction. Therefore, we use arrow that is only one-headed only. Okay, and then it goes to completion. Okay, so for example, strong base react with strong acid. Okay, after complete, it will produce salt and water. Okay, if we represent it with a graph, okay, for example, concentration. Okay, this is the reactant, this is the product. So as time goes by, the reactant will decrease, and then product will increase. Okay. For the rate of reaction, okay, after some times, all the reactant will completely change to product. Therefore, the reactant finally will becomes zero when the reactant completely reacts. Okay, now next one, let's look at the meaning of reversible reaction. Okay, the reversible reactions are the reactions that occur in both forward and backward directions, and we must use double-headed arrow to indicate that the reaction is reversible. Okay, for example, hydrogen react with iodine is a reversible reaction. Okay, what does a reversible reaction means? Reactant becomes product. At the same time, product also will become reactant. Okay. A chemical equilibrium is reached when the forward and reverse reaction proceed at equal rates. At equilibrium, the concentrations of reactants and product do not change with time. Okay, now what does this mean? Let us look at the graph. Okay, so the system is said to be at dynamic equilibrium as the forward and reverse reactions still proceed. Okay, let's see what does it mean. Okay, forward and reverse reactions still proceed. Okay, it means that the reactant will change to product. At the same time, the product will change back to reactant. Okay, and it proceed. It does not stop. Okay, for example, if non-reversible reaction, it will go to completion and then stop completely. Okay, so now let us look at the graph. What is the difference between the non-reversible reaction and reversible reaction? Okay, for example, product will increase. Okay, however, at one time, when the equilibrium is reached, okay, or dynamic equilibrium is reached, the concentration of the product will remain the same. There goes the same for reactant. The reactant will decrease, but at equilibrium, it do not change with time anymore. Okay, so let us look at this diagram and see what happens. Okay, so when reaction begin, there are no products formed yet. Okay, so there are high rate of collisions between A and B. The rate of forward reaction is high. Okay, so we can see product, okay, is getting higher. Okay, for example here, the rate is getting higher. Okay, then after that, products form collision between reactants decrease. Rate of forward reaction decreases. Reverse reaction begins. Okay, so you can see here, it start to decrease, it does not go all the way up. Okay, for example, if this is a reversible reaction, it goes all the way up. Okay, so the rate of forward reaction start to decrease. Okay, then at one time, the rate of forward reaction will be equal to the rate of reverse reaction. So at this time, dynamic equilibrium is established and concentration will be constant. Okay, so let's look at this. So you can see the rate reverse reaction and forward reaction will be the same. Concentration remain constant. Okay, so now let us revise again. What is the important thing here? Remember, reversible reaction can occur in both forward and backward reaction, and we must use reversible arrow. Let's remember this, reversible arrow. Okay, and then the concentration do not change with time. Okay, so and also remember, this is the graph, okay, concentration versus time. So when equilibrium is established, it becomes constant. If the rate, okay, if the rate is forward and reverse reaction proceed at equal rates, therefore it reach the same point when equilibrium is established because the rate of reaction is the same, it is constant. Okay, so that's all for dynamic equilibrium.